we're going to start looking at how we can take this Bernoulli trial and do the mean, the variance, the deviation for one question, scale it up just like you did yesterday, and then look at, in general, what are some shortcuts ways we could do where we didn't have to go through all this work every time. So our mean, well, let's see, our mean for one question, we could either get a 1 equals correct, 0 would be wrong, right? Either we get the question right or we don't. So let's see, what's the probability you get the first question correct? 1/4. 1/4. Okay, so there's 1/4. That would have a score of 1. And then there's a 3/4 probability you get it wrong. So the mean is just a quarter, just like what you expect. The probability of getting a question right is a quarter, so the expected value of the mean should be a quarter. So then our variance, okay, well, let's see, there's a 1/4 chance we get the question right. So then we're going to do the question correct, that's the score of 1, minus our quarter. 1 minus the quarter, that's our value, our data point, minus the mean, so that's getting our deviation. And we're squaring it because we want the squared deviations, plus, well, 3/4 chance you get the question wrong. Wrong means 0. So 0 minus quarter is getting your, that's your data point minus your mean, squaring it for the square deviation, multiplying it, so we get a quarter times, we get a quarter times 3/4 squared, plus 3/4 times 3/4 squared. We should end up with 3/16. So then our standard deviation, all we have to do is square root that. Square root of 3/16 would be the square root of 3/4. And we could get the decimal approximation. In this case, we're not really after that. We're after the scaled up version, so I'm not going to bother with the decimal approximation. So then let's look at our mean. Our mean for 3 rolls. 3 rolls, we have 3 questions. And the mean on a single question is a quarter. So we get 3/4. Let's let n equal number of trials, p equal probability success. Just so we can look at these in general terms. So basically, what did we do here? What was the 3 and what was the quarter? 3 was number of trials and quarter was
Success rates.
probability of success. So basically, in general, I think you've already picked up on this. You do your number of trials times the probability of that happening. Okay, so nothing really new there. Our variance, well, okay, we would take our 3 again, because the variance is additive. So we have 3 times 3/16, which is 9/16. No, the standard deviation will be 3/4. So our at this, I think it'll be helpful if we write out how, yeah, so we had our 3. And this 3/16 came from 1/4. 1 minus a quarter squared plus 3/4. 0 minus 1/4 squared. Alright, so let's replace it. Jackson, what did the 3 represent? Right, the number of questions, so our n. And the 1/4, what was the 1/4? Probability. Yeah, right, probability of getting one right. So p, 1 minus p squared. Okay, well, 3/4. 3/4, wasn't that 1 minus a quarter? So we could change the 3/4 with 1 minus p. And then here we had 0 minus p squared. Okay. What's, this is basically negative p squared. The opposite of p squared, though, isn't that the same as just plain p squared? So instead of writing it, let's do, instead of the opposite of p squared, let's just write it as p squared. So now what we're looking at, I'm going to be pretty close on our own here. So in our variance, let's see, if I'm looking at what's in parentheses, we have one factor of p that's common to both, and a factor of 1 minus p. So we're going to factor out p and 1 minus p. So we have n, factoring out p, so that'd be p, 1 minus p. So then it's parentheses, so let's see, we would need to take that times a 1 minus p to get back to our p times 1 minus p squared. And then what are we missing from over here, the second part of it? Just the p, okay, so plus p. Oh, 1 minus p plus p is 1. So really, we could have done our variance just by doing n times p times 1 minus p. We wouldn't have to mess with any calculations for finding one question and then multiplying by our number of trials. We could jump directly to this formula. So then, if that's our variance, what would we do that to get our standard deviation? What's that? Square root, right? So that's basically telling us that our standard deviation will be found by doing np times 1 minus p. And that's what, if you turn your page over, and some of you already did that, in general, consider Bernoulli trial with probability of success p. In n trials, the mean variance standard deviation for the number of trials are as follows. Okay, I tried to show you where those formulas came from. So that's what